Good evening, everyone. Am I audible?
Yes, yes.
Yes, ma'am.
All right.
Yes, ma'am.
Yes, ma'am.
And I have shared my screen. Kindly acknowledge if my screen is visible. All right. Thank you for your response, people. Okay. In today's session, we'll be discussing about the week 2 summary, people. So, have you all watched the lecture, video lecture of week 2?
No, ma'am.
Others?
No, ma'am.
No, ma'am. No, ma'am.
All right. Okay.
No, ma'am.
No,
All
ma'am.
right, people.
No, ma'am.
Okay, okay. So I'll tell you people in week 2 we'll be discussing about the number representation. Number representation in the sense of, let's say if I'm giving us 12. So 12 comes under which base, people? Generally if I write it as 12, what is the base value for this 12? Any idea?
It is base 10.
Base 10, right? Generally if I give it as 10, it is base 10. Yes? Okay. So there is a base binary octal. Octal in the sense of to the base 8. And hexadecimal is of base 16. And binary in the sense of base 2. Okay, so we have these numbers as well. And next, and similarly, we are having the negative number representation and floating point representation and the character representation, nothing but ASCII value, extended ASCII, Unicode, UTF, and all. And then the instruction encoding, program compilation, and the rules of the OS. So these are the topic we'll be discussing in the week 2. Okay, so first comes the number representation. So binary in the sense of
Zeros and one.
yes, exactly, zeros and ones. So let's say I have a number 15 to the base 10. So how to convert it to a base 2 then?
We divide by 2.
Yes, can you all tell me what is the value of this 15 in binary in the base value?
We do.
Just give 2 minutes, people try it. Do you all know or we can discuss?
Four ones.
Yes, good for once. Others, did you all try? Do you all know or do you want me to explain from the starting, people? Yes, people, week 1 is done. Like last week, we have discussed about the week 1. This week, we are discussing about the week 2. Okay, people, I'll just tell the representation. Give me a moment. Yeah, sorry, people, I was muted. I hope now everybody can hear me, right?
Yes, ma'am.
Okay. So for the people who need a link, I have just sent it in the chat box. You can just make use of it. And yeah, here I have 15. So 15 divided by 2, what is the quotient?
14.
Quotient.
7.
And what is the remainder? It is 1. Similarly, again, I'm dividing 7 by 2. What is the quotient? What is the remainder?
3.
6 and 1.
3.
Divide the rest.
Remainder 1.
Remainder is 1. Again, divided by 2. Then
1.
Quotient
quotient
1
is 1.
divided by 1.
Remainder is 1. You have to write from bottom to top approach. Nothing but 1, 1, 1, 1. Okay. Similarly, let me take 12 here. So what is the value of 12? So first divided by 12. Sorry, divided by 2. What is the quotient?
4.
6.
That is 6 is the quotient, right? So 6 2 is 12. What is the remainder value?
0.
0.
Okay. So again divided by 2.
3.
3.
Yes. Quotient is 3.
0.
Remainder is
0.
0 again. And again divided by 2.
1.
1 and 1.
Quotient is 1 and
1
remainder is
and
0.
yes. So if I write it from bottom top approach, so it will be like 1 1 0 0 to the base of 2. Is it clear now, people?
Yes.
Yes, ma'am.
If you want to check it, you can just make this notation. Generally, the numbers are from 1, 2, 4, 8, 16, and then 32, 64, and it goes on. So now I have to fill 12. So how to fill 12? So first I'll check it with 16. On checking with 16, is 12 is greater or lesser?
Yes.
Twelve is
It's
lesser.
greater. So I have to go with 8. So 16, sorry, 12 minus 8.
4.
4.
So fill it with 4, remaining are all zeros. So 1100 is the answer. That is what I have got as well. Is it clear?
Yes, ma'am.
Great. So this is the way to convert. Either you can use this division method or you can use this filling method also. Is that clear?
Yes, ma'am.
Yes, ma'am.
Can everyone be able to understand this?
Yes. Yes.
All right. Then I'll give you the set of numbers, people. So the first number is 8, and the next number is 56. The next number is 67, and the next number is 9. Okay. Can you all try these things, numbers, people? Just give the binary representation of these numbers. That's it. I'll just give 3 more minutes, people. Just complete it and send it in the chat box. Okay. I hope everybody tried, right?
Yes, ma'am.
Anybody have any doubts? No, right? Okay, we'll see the answer for this people. So for 8, what is the value? So for 8, we have value as
1 triple 0.
1,000. Okay, so next for 9, it's 1,001.
0.
Okay, and for
1 double 0 1.
yeah. And for 67, this 1,00,00,11. Is it so?
Yes, ma'am.
And how about 56? 1.
1,000,000.
Excuse me, ma'am.
Yes.
Ma'am, 467 is it 1 triple 0 double 1?
For 67.
Isn't it 1 triple 0 double 1?
No. 1,00,00,11.
Okay.
For 67, right? Oh, you're talking about 56.
No, ma'am. No, about 67.
67 is 1,00,00,11.
Okay.
Because in 64 we'll fill 1, which means 64 plus 3 is 3 is 67, right? Now can I add it up? 64 plus 2 plus 1. It's 67. Is it clear?
Yes, ma'am.
For 56, 32 plus 16 is 48 plus 6 is 56. And then 000. Is it clear? Have you all got the same answer, people?
Yes, ma'am.
Yes, ma'am.
Ma'am, can you please explain the second one again?
Could you speak a bit louder?
Ma'am, could you please explain the second one again?
56.
Yeah.
Okay, so for 56, I have to check with 16. So, 32, sorry, 64. On comparing with 64, is it greater? 56? No. So I have to, actually 56 is lesser than this, right? So I have to fill it with 32. So on 32, like 56 minus 32, what is the value now?
24.
Yes. So 24 comparing with 16?
It is greater.
So I have to fill it with the 16 also. So on subtracting 16,
8.
yes, so fill it with 8. After that,
We subtract 4 from 8, right? After that.
yeah. So 16 after subtracting it becomes 0. So all the remaining values are filled with zeros.
Oh, okay.
It's clear now, right? Is it clear to you all? So while representing, you have to mention this braces as well. So the braces 2. Similarly here also within the braces 2. Because to represent it's a binary value. Is it clear to you?
Yes, ma'am.
Okay. So similarly, we have to check with the octal values also. So octal in the sense of to the base of 8.
Okay.
So instead of dividing by 2, we have to divide it by 8. That's it. Let's say I have the number as 26. I have to convert it. So this is of base 10. I have to convert it to base 8. So what I need to do? 26 divided by 8. What is the remainder? And what is the quotient?
3.
Yes, 3 is the quotient. And what is the value remainder?
2.
So same approach. 3, 2. So here, previously what I did, I have taken 1, 2, and then 4, 8. So how that comes? 2 to the power of 0 is nothing but 1. 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. Is it so?
Yes, ma'am.
Yeah. Similarly, here I have to write it as 8 to the power of 0 and 8 to the power of 1. So what is 8 to the power of 0?
1.
1.
1. So 1 into 2, what is the value?
2.
Okay. Yes. 8 into 3. 8 to the power of 1 into 3. What is the value?
24.
24.
Yeah, 24 plus 2.
26.
26.
Yes. That's it. We have got the value. Is it clear to you all?
Yes, ma'am.
Ma'am, how do we convert decimal values?
That is what I'm telling you. Divided by 8. How we did for binary. Instead of 2, here we are taking it as 8. That's it.
No, I mean after point, the decimal.
That I'll discuss. We'll discuss now, people. So first, let me just go ahead with this binary conversion. Then I'll tell you how to convert. Is it clear?
Yes, ma'am.
Yes, ma'am.
Everybody can understand, right?
Yes.
Okay. Let's say next number is 15. How will you convert it to a octal? Okay, let's say I'm dividing it by 8. What is the quotient and what is the remainder?
1. 7.
1 and 7, right?
7.
So I have to write it as 7
One.
to the base
17.
8 equal to 15 to the base of 10. Okay, now my question is we have to check the 17, which is nothing but 8 to the power of 1 into 1 plus 8 to the power of 0 into 7. So what is the value? What is 8 to the power of 1 into 1? What is the value?
8.
8.
8.
Plus 8 to the power of 0 into 7 is 7. So 8
7.
plus 7.
15.
Yeah, that is the value we have got. Is it clear to you all?
Yes, ma'am.
Yes, ma'am.
Okay. And generally, if
Yes,
I'm
ma'am.
just taking the great. Generally, if I'm taking a number 8, so what are the possible values for the 8? As a like these values can be of what are the possible values? In binary, we know it's zeros and ones only. Here,
It is from 0 to 7.
yes, how it is 0 to 7? Because generally 8 can have the reminders from 0 to 7, right? Generally, if I divide a number, let's say 2, So what are the reminders possibility for this? 0 and 1. Similarly, for 8, we have the remainder possibility from 0 to 7. That's it. Is it clear?
Yes, ma'am.
Similarly, if it is of 26, it have the remainder possibility from 0 to 25.
25.
Yes. So whatever is the n value till n minus 1 is the uh, like the remainder values. Is that clear, people?
Yes, ma'am.
Great. So can I give you the some other numbers for base 8 to convert to base 8?
Yes, ma'am. Sure.
Yes, ma'am.
Okay, great. I'm giving the numbers this side. 48, 56, and then 9, and then not 56. Let me give 17. Oh, 17 already. Oh no, 17 we haven't done. And next is of 62. Yeah, so these are the number, people. Just give it a try for this. Okay, I'll just give 3 minutes for this. Just give it a try.
Ma'am, can you show the screen? What are the numbers?
I hope everybody completed, right? Any doubts so far, people? No doubts? Great. We'll discuss the answer and then we'll go ahead with the next conversion thing. Okay. So the thing is, I have to convert to octal and these are the numbers, right? 48. So for 48, what has to be done actually? So generally, I'll divide it by 48. So what will happen? 6 8s are 48, remainder 0. So what is the answer here for this?
60.
60 to the base of 8. How about 70?
Two and one.
Yes.
Two
60,
subtraction.
it was a 16 and remainder is 1. How about 9?
1
One and one.
Yes. Because 1 8 is 8 plus 1 is 9. Okay. And what is, how about 62?
7 will be the
7 and
quotient and
6.
6 will be the remainder.
Because 8 7s are 56 plus 6 is 62. Is it clear now, people?
Yes, ma'am.
Yes, ma'am.
Okay. So next is of, let's say I have the octal number, I have to convert it to a binary. Nothing but let's take a 11. Okay. So what is the binary value of 1? In 3, we have to represent with the 3-bit binary value. So how to represent 1 then? Or let's take some other value as 6, 60. How to represent 6?
Zero,
4
1, 0.
4 plus 2, right? We have to write in the 3-bit. So I have written as 110. How about 0? How to write it in a 3-bit binary value? It is 0, 0, 1, 0, right? Is it clear?
Yes, ma'am.
Yes, ma'am.
This will be the base of 2. If you want to check whether it is giving 48 or not, you can use this method. 32, 16, 8, 4, 2, 1. What is 32 plus 16?
Can you explain again, ma'am?
So let's say the number is represented as, sorry. Okay, let's take the value as 1, 1, 0, and triple zeros. 1, 2, 4, 8, 16, and 32. What is 16 plus 32?
48.
48.
That is the value to the base 10, right? Which means my number conversion from octal to binary is correct. Is it clear?
Yes, ma'am.
Similarly, if it is of 21, how to use the 3-bit for 22? I mean, for 2, how to represent? Zero, 1, 0, no?
And 001.
Yes, for 1 it is 0, 0, 1. So now add it like it is 1, 2, 4, 8, 16, and 32. So 16 plus 1. What is the value? 17, which is to the base 10. So which means the answer is right. Is it clear?
Yes.
Okay, then can you all try converting 11? So I'll just give them values here. 11 to base 2 and 76 to base 2 and 17 to base 2 and 32 to base 2. Can you all try it now? Octal to binary values. Can I give you 3 minutes again? Can you all try it? Any doubts, people? Do you want me to explain anything again? Okay, then try it now, people. Yes, have you all completed, people? Any doubts so far? Great. So actually, for 11, how to represent it? It has to be like 0, 0, 1, again 0, 0, 1, which means 8 plus 1 will get it as 9. Similarly for 76. How about 76 people?
111
Yeah, for 76, I'll just give it a 7, which is nothing but 111. Then for 6, 110. Is it right, people? If I fit that one here, so 111, 110. Is it clear, people?
Yes.
Okay. So similarly, I have to convert 17. For 17, 1 has to be 001. Then,
111.
yes, so next has to be the 7, which is nothing but 1, 1, and 1. So I'll get it as 000. I mean, like 001 and all ones, which is nothing but 8 plus 4 plus 2 plus 1, none other than 15, right? Similarly for 32. For 3, we have to use 011. For 2, we have to use 0.
010.
Yeah. So these are the representations, people. Any doubts so far?
No.
Okay. So next is of decimal value, which we generally write, no, the same thing. Next is of a hexadecimal value. So in hexadecimal, which means it's to the base of 16. So what are the possible reminders?
0 to
0 to
15.
15.
0 to 15.
Yes, 0 to 15. But generally, we can have a single digit, right? We cannot have a double digit. So from 10, they're using the characters A. So for B, then what is the value? I mean, like 11 is represented as B. How about 12?
C.
C. Yes. And how about 13?
E.
D.
D.
Yeah. And how about 14?
E.
E. And how about 15?
F.
Yeah, that's it. So 0 to 9 you can use it normally, and from 10 to 15 you can use it 0 to F. Is it clear? Let's say the given number is 31. So how to represent 31?
2F.
So dividing it by 16, what I'll get? 116 is 16, remaining are
15.
15.
15. So 15 can be represented as F. So 1F is the answer. Is it clear?
Yes, ma'am.
Yes, ma'am.
Okay. Similarly, let's say I want to put 32. Then
20.
we'll get it as 20. 2 is the quotient, 0 is the remainder. Is it clear to you all? Great. So can I give you some numbers to convert people from decimal to hexadecimal?
Yes, ma'am.
Okay. So let me give the number as 41 and 12 and 67 and 92. So try these numbers. But again, I'll give you just 3 minutes of time. Just complete it as. Okay.
Ma'am,
Yes, please say.
ma'am, can you explain this hexadecimal approach again?
Yeah, sure. Okay, so the thing is, let's say I have the number as 1 minute, I think. Okay, leave it. So let's say I have the number as 41. So what I should do here with 41, I have to divide it by 16. So on dividing by 16, what will be the quotient?
Ma'am, the answer.
I'm 2.
Yeah, we'll get it as 2, which means what is the quotient? I mean, what is the remainder then?
9.
9.
Yeah, because 32 plus 9 will get it as uh, like this 41. So now, what is the value? I have to write it as 2 and 9. That's it. To the base of 60. Okay. So similarly, let's say I have the numbers from 10 or 12 or something like that. Then is it possible for me to represent that? One minute,
Yes,
people are
ma'am.
patient. Okay, so if it is 10 to 12 or some other numbers, how to represent it? Can we represent it as 10 or 12, something like that?
No.
A, B, C, D.
Yes, in those cases it is not possible. So that's why what are we trying to do is we are just using the characters from A to F. Is that clear to you all?
Yes, ma'am.
Okay, Kana, you have Vasnu. Is that clear for you now? Now, similar has to be done for the other numbers like 12, 67, and 92 as well. Is that clear? Yes, everyone. Okay, so for 41, the answer is 29. How about 12? None other than just C.
0, C.
That's it, C. Okay, and how about 67?
4, 3.
Yes.
4, 3.
Yeah, because we know that we have to divide it by 16, right? So we'll get it as 4. Okay. So, and how about the remaining? Actually, what is 16 into 4? We'll get it as 64, right? So the remaining is 3. So we'll get it as 4, 3. Is it clear, people? And similarly, 92. So 92 divided by 16?
5, C.
Yes. 5 plus 12 will get, so I can write it as 5C to the base of 16. Is it clear to you all?
Yes, ma'am.
Yes.
Okay. Now my question is it possible to convert from hexadecimal to binary?
Yes. I think
Yes, how to do that? So for octal, how many bits you have used?
8 bit.
No. Octal we have used 3 bits, right, for converting it to a binary. If it is 7, I have represented as 111. You remember that?
Yes,
Because
ma'am.
there I'll have the values to the maximum of 7, right?
7.
Because the remainder for 8 is what? Maximum is 7, right? So 7 can be represented in the 3 bits. So for 16, what is the remainder? We have the reminders from 0 to 15.
0 to 15.
Yeah. So what is the possible number of bits are required for representing 15?
4. 4.
Yes, 4, which is nothing but 15 is represented as 4 ones. So here also, if it is 29, represent 2 in 4 bits. So I'll get it as 0, 0, 1, 0. How about 9?
1, 0, 1.
1, 0, 0, 1, right?
Yes, sir.
Yeah. So now I have to use 0, 1, 2, 4, 8, 16, 32. 32 plus 8 plus 1. What is the value?
41.
We have got it, right? So this is how we have to convert from the hexadecimal to a binary. Can you all try it now?
Yes, ma'am.
Okay, I'll just give you the values here. First is C, second is 43 to the base of 16, converted to a binary. And next is a 5C to the base of 16. And the next number is of 20 to the base of 16. Can you all try this number, people? I'll just give 3 minutes again. Try completing it. Okay. Yes, people, have you all completed, ma'am? Any doubts so far? I could see only one person have replied. How about others? People, can you able to understand first?
Yes, ma'am.
Yeah, okay, Sadashiva. Others? Okay, I'll just give one more minute, people. If you have any doubts, you can ask me, okay? Yeah, sure, ma. I'll just repeat it. So the thing is, we have the hexadecimal. So what I have to do is I have to write a 4-bit value, which is nothing but if it is C. What is the value of C? Actual value 12. So how
12.
to represent in the 12? It's 8 plus 4, remaining all zeros. So this will be the binary value of 12. I mean, like C. Hexadecimal to binary. Similarly, 43. So 4 has to be written in such a way that 0 1 0 0. How about 3? It's 0 0 1 1. So on combining all this, we'll get a value of a, like, on combining all these things, this is the value of a binary. If you check for decimal also, you'll get it. Is that clear? Is it clear now, Amit?
Yes, ma'am.
I didn't understand your question, Varsha. Okay, okay. Yeah, similar to that. That is nothing but hexadecimal has to be written in a 4-bit value. And based on that, you have to say which binary value you're getting. That's it. Okay, why 4-bit in the sense of 16 can have a maximum of, what is the maximum remainder for 16? 15, right? So how to represent the 15? Using 4 bits. So number of bits required for representing 15 is 4. So that's why we are using a 4-bit representation. Is that clear? Great. Okay, so similarly, we can have a conversion from hexadecimal to octal also. How to convert hexadecimal to octal? Any idea? Actually, for hexadecimal to octal, there is no straight conversion. So what we have to do here is hexadecimal to decimal. Then, of course, we have to use the decimal to octal conversion. That's it. So this is the way to convert from hexadecimal to octal. Is it clear? Yes. Yeah, you can do that also. That also works. Okay, but general conversion has to be like hexadecimal to decimal and decimal to octal. Do you want to try numbers for these things, people? Okay, I'll give you the numbers. This C, 56, and 2C, and 1F. Convert these number to octal. So these are all to the base of 16. I'll just give 3 minutes, people. Try completing it as well. Okay. So has everyone completed? No? All right, great. So now let's go to the answer part. So here I have to convert C. So C in the sense of it is nothing other than 12, right? So how to write the 12 then?
1 4
No, 1 1 0 0, right? Because 1 is converted to this way, that is 0 0. Sorry. I'm converting it to a binary action. Sorry. Okay, so converting it to a decimal, what I need to do is, sorry, octal, what I have to do is I have to divide it by 8. So 1 and 4, right? So this is the answer, right?
Yes, ma'am.
Okay. So similarly, I have to convert the 56. So 56 to the base 16. So I have to convert it to a decimal.
1
Yes. So what I have to do is, here I have to take 6 into 16 power 0. What is 16 power 0?
6.
And 5 into 16 power 1. So what is 16 into 5?
30.
86
80 plus 6 will get it as 86, right? So that will be the value for this one. Okay, so now 86 has to be converted to octal. How to convert decimal to octal?
1 2 6
So again, this 86 has to be divided by 8, right? So I'll get it as 10. So 10 has to be again divided to, so let's say 86 divided by 8. So I'll get 10 and 6. 10 is again divided by 8. So I'll get it as 1 and 2. So 126, right? Is it
Yes,
right?
ma'am. Yes, ma'am.
So next is of 2C. So what is C is 12. And what is the value of 2 is 2 only. So 2 into 1 plus 2 into 16. So what is the value?
44
54 or 44?
4 44 4
44, right? So now this 44 has to be converted to a octal. Then what I have to do? 44 divided by 8. 8 5s are 40, remaining is 4, right? So I'll get 54 as the answer for this. Is it clear?
Yes, ma'am.
And next is of 1F. F means 15. So 1 into 16 plus 15, what is the value? 31, right? So 31 divided by 8, 3 and 7, 37, right? Is it clear, people?
Ma'am, is it 37 or 35?
Only 37, no? Because 8, yeah, because you will get 8 3s are
Right, no, 37.
44 plus 7 is 31, right? So it's 7 only.
Yes, ma'am.
Five. Is it clear to you all?
Yes, ma'am.
To everyone?
Yes, ma'am.
Okay, now am I audible now? Is my voice is clear and
Yes, ma'am. Clear, ma'am.
Yes.
okay. So next is of negative representation. Negative representation in the sense of we are giving the sign. So far we have seen only the positive numbers, right? So what if the number is a negative? Nothing but minus 18 or minus 7 like this. So to represent this, we have to use a sign value, none other than whatever is the most significant bit. So let's say I'm writing the value as 1100 like this. So here the 0 is the most significant bit and this 1 is the least significant bit. So if it is 0, we'll say it is a positive. If I change it to 1, that will be set as a negative number. Okay, so instead of this, how I can write is 1, 0, 1, 1, 0, 1. This is a way of writing a negative number. Okay, or else what we can do is we can take a 2's complement. Do you all know what is 2's complement?
Yes, ma'am, I know.
Yeah, what is 2's complement? Can anyone say what is 2's complement? Okay, I'll tell you people. Let's say the number is 0, 0, 0, double 1, 0, 1. So first I have to take the 1's complement. So what does mean by 1's complement? 1's complement is nothing but invert all the numbers. That is, this is 0. So convert to 1. 0 to 1, 1 to 0, 1 to 0, 0 to 1, 1 to 0. So now if I add 1 to it, so what is the value I'm getting? 1, 1, 0, 0, 1, 1. So this is what is the 2's complement. Is it clear?
Ma'am, can you explain the negative numbers again?
Yeah, kind of a negative number only. I'm saying that either you can just change the MSB to 1. That is one thing. Otherwise, what you can do is you can take the 2's complement to represent a negative number. 2's complement is nothing but first you have a given number. This is the given number. Okay, so the given number has to be taken 1's complement. 1's complement in the sense of invert all the numbers. If it is 0, convert it to 1. 1 means 0. Like 0 to 1, 1 to 0, like that.
Yes, ma'am, I understand.
Understood, ma'am.
Okay. So then after 1's complement, you have to add 1 to it to get the 2's complement. Is it clear? So by this way, you can represent the negative sign, I mean negative values. Okay. Is it clear to you all? You can take it as a negative as well as positive number. If I'm taking as a positive number, I'll say it as 9. If it is a negative number, I'll say it as minus 1. It is like that. Kana, as of now, we are having 1's complement and 2's complement for these using purposes. Okay. Right. Next is of a floating point representation. So floating point representation in the sense of, as you all asked, right? Like what if the values are of point precision, like 0.12 or 0.3. So for that things, we can use this Mantissa conversion. Okay. So Mantissa conversion in the sense of a floating point can be represented as -1 to the base of 8 into. So this -1 represents the sign bit. Okay. Like -1 to the power of whatever the sign is. Okay. So yes means if it is 0 means it's positive. If it is 1 is negative. So anything per 0, what is the value?
1.
Yes. And if anything per 1, we'll get the same value, nothing but
Same
minus.
number.
So this is to represent the positive or negative value. After that, we have to take the 1 plus mantissa into 2 to the power of exponent minus base by s. Okay, that is for the single precision or double precision. Based on that, that depends. Okay, so if it is of single precision, we'll use 127 as the ranging component. And if it is of double precision, we are using 1024, nothing but 0 to 1024. Okay, so it's for 64 bit. So this is the way people. So first is the sign bit, exponent, and then the mantissa. Let's say we have the number is 5.75. So first we have to write how to represent 5. So how to represent 5? How to represent 5 people? Yes, perfect. It's 101. So first we have to write for 5. It is nothing but 101. So next I have to take it for 75. Okay. So for 75, what I have to do? How to represent 75? So if it is after point, I have to multiply it by 2 only. Okay. So how to do this, people? Any idea? Like how it got 1 to the base 1? I mean to the base 2? Okay. So we have to multiply it by 2 first. So what is 0.75 into 2?
1.5.
Yes, we'll get the value as 1.5. So take this 1 separately. That is what we are getting as 1. So next 0.5 is there. So 0.5 into 2?
1.
Yeah, 1. So now take this integral point. So 1, 1. Is this thing clear?
Yes.
So then what are we trying to do is we have to do the normalization point. So for normalization, they are just using single point precision. So what I have to do is, yeah, can you see here? Sorry, 1 minute, yeah. So this is what they are trying to do. So first we have to take the bias value, that is 127. So 2 is the exponent which we are taking. So 2 plus 127 is 129. So we have to take the number of 129. Then I have to give this value. So that is nothing but we are trying to represent in the 23 bits. Okay, that is 0, triple one, and remaining all values are zeros to make it to a 23 bits. Okay, so now I have to combine all. So it is a 1. 1 is to represent whether it is a positive or negative. It's negative, sorry. It's for sign bit, right? One is for negative and the other is for the positive. So sign bit is 1, and this number is taken, that is 1. We have to represent, and next is 120, 23 bits representation is done. Okay, so this is how we are trying to convert the base, floating point to a binary value. Is it clear?
Yes, ma'am.
Any doubts so far?
Can you give another examples?
Yeah, sure. Let's take the number as 7.25. So how to convert it to a binary, people?
First we can
So first I have to convert the 7. So how to convert the 7?
111
Yes, 111 point. We have 0.25. So what I have to do? 0.25 into 2. What is the value?
0.5
0.5. So we have to take 0. Then 5 is here. So 0.5 into 2.
1
1.0. 0. So we are stopping it. We have got 1. So 0, 1. So 111.01 is the combined value like this. Is it clear? Is it clear?
yes ma'am.
Yes.
Great. Okay. Now, if it is double point precision, nothing but we have to use the 52 bits. So here you have used 23 bits, right? 1, 8, and 23. Here, 1, 11, and 52 bits. That's it. So by that way, we are trying to show this number. But the positions are correct. First has to be sign bit, next has to be the exponent, and next has to be the mantissa. None other than the after decimal point, what value is that? That has to be represented. Is it clear to you all?
Yes, ma'am.
So next is of ASCII values. So ASCII value in the sense of it is a let's say we are having a characters as A, B, C, D. But will the computer be able to understand what is A, what is B? It is already in the here you can check in the course. You have this supplementary contents there. You can find it. I hope now it is clear, right? Yeah, great. Okay, so now computer cannot be able to understand what is 0, what is A and all. So for that we'll use this ASCII values. So what is the so we have ASCII value from A, B, C till Z. Similarly, we have a separate ASCII value for A, B, C till Z. Similarly, we have ASCII value for character 0, character 1 till character 9. Okay, so for this one, we have the value as 65 till 90. So 65 and B means it's 66. Similarly, it goes on till 90. And for lowercase a, it starts from 97 and this is of 98. Similarly, it goes till 122. So it is, it's you can just do one thing, people. Let's say I'm remembering the 65. So 65 plus 32, what is the value?
97.
Yes, that is the value of a lowercase a. Can you be able to understand this? Similarly, if you remember 97, you can just get the lowercase, uppercase values. Okay. Okay, fine. So similarly, next is of a extended ASCII. So extended ASCII in the sense of we have the special characters also. Like let's say I'm just having some characters like upper quote A or some other extended characters can also be used in this extended ASCII. Okay, so that is how we are getting the 256 unique characters. Okay. Okay, so next is of a Unicode. Unicode in the sense of it supports all the writing system across the world. Let's say they have some Chinese character. For that also we have some code points. So that is what is the Unicode. Okay, and next is UTF-8, which means Unicode Transformation Format. So here I'm just writing as U plus 0041, something like this. So what I can do is I can just convert it to a zeros and ones to support the byte. Like it support all the characters as well, right? Is it clear to you all? And next is of the instruction encoding in a computer. So generally, instruction encoding in the sense of we have to give the instructions as like instructions are always be in the binary values. Okay, that is that the CPU can decode and execute. And next is of the instruction. So instruction contains the opcode and the operands. So opcode in the sense of operation code. What operation to be done? Either it is a like register. We are uploading it. I mean, like loading into the register, or do I have to do any process like storing or something like that? And operands in the sense of its registers and immediate values in memory addresses. These comes under the operands. Okay, so these are the components of an instruction. So instruction will be in the binary numbers. So memory address in the sense of like what location it is in RAM, and immediate value is like instruction itself, like constant embedded things. Okay, and next is of the instruction formats. It will be either RISC or CISC. RISC in the sense of reduced instruction, like simple instruction. If I want it to be complex, if there is a complex instruction that is to be done, we can use the CISC. That is the complex instruction set computing. Is that clear? And next is the program compilation. So program compilation has some stages like pre-processing, compilation, assembly, and linking. So generally compilation in the sense of we have some high level code. I have to convert it to machine code so the machine can understand and it will execute whatever is required. So that is the compilation process. So for that it includes the pre-processing, compilation, assembly, and linking. Pre-processing in the sense of we are including some library files or some header files. So it has to decode it, like what it is used for. So you all know how to write a basic C programming, people?
Yes, ma'am.
Huh. Anuj, you can
Yes,
just find in the course, ma. In the course, you can just find this page, like complementary contents. There you can get the PPTs and slides. Okay. All right. So in the basic code, what is the first line you will write in basic C programming?
hashtag include stdio.
Yes, hash include. So what it is used for?
It is used to import the header file.
Yeah, which includes the library files like for input and output processes, right?
Yes, ma'am.
So similarly, like if I'm including the hash include stdio, then I can use scan of print of things, right? So similarly, like whatever the finds I'm giving as the header, so that will be wrapped up. Like that will be open the wrap, and it will just say, okay, for these things I have to use it. So that is what is pre-processing. So if there is a hash include stdio, then only I should use scanf and print. Otherwise, those lines are not processed. So that is what is the pre-processing. And next is the compilation. And next is of compilation. So compilation in the sense of pre-processed code into a assembly level code. So in that only it will check for the syntax, semantic, and intermediate code optimization and code generation will come. So now, syntax analysis in the sense of, let's say I'm giving a scanf. So what should be the format of scanf? So first I have to give it a scanf, then a format specifier has to be there, then whatever the variable it is there, and then semicolon. So this is the line, proper line for the scanf, right? Let's say if I didn't give a proper variable here. So let's say for integer, I'm just giving as a string variable here. So what will happen? So this comes under the syntax or semantic. Semantic is nothing but let's say whether I'm using the proper variables or not. That will be checked. So syntax in the sense of let's say if I miss the semicolon, that comes into the syntax analysis. Okay, it will check for the syntax and semantic analysis. Then it will create an intermediate code. Okay, because I have a high level code which is which has to be converted to a assembly level language. So that is there. And then it improves the efficiency of the code which is generated, and then the optimized code is converted into the assembly level code. Okay, then assembly level code, what it will do? It will convert from the assembly level code to the machine level code. Okay, nothing but machine level code is nothing but zeros and ones. And the last stage is of linking. So whatever the files we have, that is taken into a single executable file. Okay, so that involves the symbol resolution, address binding, and library linking. And next is the role of the OS, that is the operating system. What do you know about operating system, people? Is what is the operating system, that is OS? And a compiler is like a code, like it is used to conversion process that help us to interact with the underlying system. Yes, perfect, people. It's an interface between the humans and the hardware. Perfect. Good. So it is to interact. Let's say whatever the computer hardware says, it will be just it will tell the like from software. It will just what you can say. If you have to do some normal computation process also using the OS only, we can be able to do it. Okay, it manages the computer's hardware and software both. Actually, it is an intermediate one between the user and the computer hardware. It will just go till the underlying servers and then it will just do the service whatever is required. And the functions of the OS are process management, memory, file system, device, user interface, and security and access control. Process management in the sense of, let's say I'm giving 2 or 3 more process. So what it has to do? A process has to be created, then it has to be scheduled, for which we need the proper communication. Okay, so that let's say if it some has some priority and all, so based on that the process has to be done, then at the end the process will be terminated. Okay, so scheduling in the sense of allocating the CPU time to it. So then creation and termination. Synchronization is to communicate so that no two processes can conflict each other. And next is of a memory management. So generally memory in the sense of, let's say I have to do some process for which the memory has to be allocated. Once the process is done, I have to deallocate the memory as well. Okay. And here we have a main memory and virtual memory. Main memory is the actual RAM and virtual memory is the extra memory which is in the disk space. And next is of a file system. It is similar to the process only. Like file has to be created, then a directory has to be done, and the permission has to be given. At last, if it is not required, we can delete it. Okay, we can just write it in either the virtual memory or wherever we have to write it. And next is of the device management. Device management includes the device drivers and the input output operators. Input output operations in the sense of, like if I have to display something or if I have to get the input and all, that comes here. And device drivers which communicate with the hardware devices. And next is of a user interface. We have a command line and the graphical user interface. Graphical user in the sense of, like if I have to like visual representations like windows or icons or menus like that. Command line is nothing but entering commands like text based sentences. And security access in the sense of who has to hold it. Like it has to identify the correct login credentials and what they can do. You can see in G Sheets, right? In G Sheets, we can just give some people as a only commenter or only viewer, something like that, right? So I'm giving the correct people, so that is the number of users, and next what they have to do, what they are authorized to do. So it depends on that. And the last topic is of booting. So booting in the sense of starting the computer and loading the OS to a memory. So first I have to power on, and then it has to do the check like whether it's working finally or not. Then the bootloader, that is like once the device is starting, it has to load the bootloader. Then OS starts like it will be fed to the main memory, I mean like memory, and then the OS starts to do whatever is the process involved. Okay, next is a bootstrap. Bootstrap in the sense of the computer loads and initializes the OS. Let's say it's already off, now I'm turning it on, so what the operating system has to be done. So first it has to initialize the CPU, then it has to do the BIOS operations. That is to check the hardware, then boot the order, boot order to find the bootable device. Then we have to do the bootloader, then the OS has to be loaded to the memory, and the control is given to the OS. Once the OS is loaded into the memory, the OS will start to take its control. And BIOS in the sense of its basic input and output system. So it's nothing but stored on the motherboard, which is nothing but it initializes the hardware during the booting process. So first is the power on self test, that is it checks the integrity and functionality. Then again the bootloader stats, then BIOS setup utility, which configure the hardware systems. And then hardware utilization is done, then system firmware interface is done. Okay. So these are all the topics that is discussed in the week 2 people. Do you have any doubts so far? Hi, yes. Actually, you will have the content from week 1 to 4. That is what is the content of qualifier exam. So qualifier will be like a quiz based exam, like quiz exam. So you have to just give the answers accordingly. And firmware is nothing but it's a like what to say, it's in the like permanently programmed in the hardware device to do what are the functions has to be done. That is what is firmware. You can say that it is between the hardware and software. You can take this as a firmware. Like when you're operating the TV and all, like if you press some button, what it has to do, it has already something written there, right? Like that. There is no negative marking, and you have to go to the centers for writing quiz exams. Actually, in addition to that, you should watch the video lectures which is given in the course, along with assignments and practice questions. Okay, any other doubts, people? Okay, if you have no doubts, you can end the session now. Thank you, everyone.